Hey everyone, welcome back. Today we're going to take a look at a few basic techniques in basic programming language that we need to try to avoid when we're creating our basic programs, because they'll probably screw you up as they have screwed me up in the past. And I'm sure a lot of you are probably already familiar with these things that we need to avoid, but I'm just going to go through a few techniques today that we should watch out for to not do when we're making our basic programs. So the first one we're going to take a look at is for next loops, and specifically for next loops with embedded if statements in them. So let's take a look at a program here, and I'm just going to type a program into my Aquarius Plus emulator, which is a fantastic emulator and a fantastic computer. If you're at all interested in basic programming, then I strongly suggest you take a look at the Aquarius Plus emulator because it's fantastic to use. And the Aquarius Plus Basic, which is called Plus Basic, is constantly, even as we speak, being developed and upgraded and adding all sorts of new and cool features and commands to it. All right, so getting back to our video topic for today, things we should not do when programming in BASIC. The first one, as I mentioned, has to do with for next loops. So let's type in a simple program here. Line 10, for f equals 1 to 3. Line 20, if f equals 2, then print high. Line 30, next f. This should be a very straightforward for next loop program that you're all familiar with. And if we go ahead and run it, you'll see it prints the word high, which happened when the variable or loop counter f reached the value of 2, because of course in this loop it counts from 1 to 3. And if we print out the current value of f, what would we expect it to be? Well, let's take a look. Print f, and it prints the value 4, because that's how for next loops work. It keeps incrementing the loop counter variable until it exceeds the maximum range, which in this case is 3. So it incremented it up to 4, and then it dropped out of the loop because it's higher than the range that we specified in our initialization line here, for f equals 1 to 3. So this is working exactly as we would expect. Now, in some versions of BASIC, actually many versions of BASIC, you are allowed to include more than one command on a single BASIC program line, separated by colons. So we could rewrite this program. I'll type new to erase the current program, and we'll start again. And we'll say this time, line 10, for f equals 1 to 3, and then a colon, and then if f equals 2, then print high, another colon, and then our next f. Okay, so now what would we expect to happen when we run this program? Now on the surface it might seem identical in functionality to our initial program at the top here, but you'll see when I run it, it doesn't print the word high any longer, which is supposed to do when the loop counter variable f reaches the value of 2. So it should be counting from 1 to 3, and then when it hits the value 2, it prints the word high, but in this case it didn't print anything. So why is that? Well, again, let's take a look at the value of f. Print f, we can see it has a value of 1. So I'm sure most of you have probably figured out what's gone wrong here, but what's happened is, since we've embedded an if statement in the middle of our basic program line, it is checking to see if f equals the value of 2. And since the first time through f equals 1, since it's counting from 1 to 3, the first time it goes through the loop, f equals 1, so this conditional statement is false, which means it ignores everything after this check. So this then print high, next f gets ignored. So the print high gets ignored, which is fine because we don't expect it to get printed when the value is 1. But also what's getting ignored is everything on the rest of this line after the if statement, which in this case we have our next f statement being ignored as well, which means this loop is not going to progress properly. So that is the first thing to watch out for in today's video, is to not embed, or at least to be careful when embedding if statements in your basic program lines, because anything after the if statement will be ignored if the condition that is checked for is false, which is sometimes what you want to do. So just be careful when you're embedding your if statements. All right, so let's clear the screen here. Type in a new program. Okay, so now the second thing we want to take a look at has to do with subroutines. So let's write a program here that uses a subroutine. So we'll say line 10, go sub 100, line 20, stop, just because we don't want the program to just run into our subroutine automatically. So line 100, here's our subroutine. We'll say print now in the sub, short for subroutine. And then line 110, go to 500. And then line 120, return. Then line 500, print now at 500. Okay, so what's going to happen here? Well, at line 10, we have a go sub which go subs line 100, which is down here, which basically just jumps over this stop instruction at line 20. At line 100, we're going to print now in the sub. And then we have a go to command following it that goes to line 500, which essentially jumps over our return statement and goes to line 500 where it prints now at 500. So let's go ahead and run this. And there we go. We have our now in the sub output and our now at 500 output. So this is exactly what we would expect our program to do. And you might think, okay, well, what's wrong with this? It's doing what we expect it to do, right? Well, what's wrong with it, or what could potentially cause an issue with your program, is that you can see since we jumped over our return instruction here, we jumped out of our subroutine without ever hitting our return instruction. And the problem with that is, as soon as the computer issues this go sub instruction, it needs to know where to come back to continue executing the program when it does hit the return statement. And the way it does that is it saves the line of the program it's supposed to come back to in something called a go sub stack. So if you're familiar with assembly language programming, you would be familiar with the concept of a stack, which is an area in memory that the computer uses to store values that it needs to do stuff. In this case, it's storing the value of a line number that it needs to know where to continue executing the program when it returns from a subroutine. But in this case, it never returns from the subroutine. And the problem with that is when a program does return from a subroutine after hitting a return statement, it essentially tells the computer that it no longer needs to remember where to continue executing the program because it has already returned, so it continues executing the program where it's supposed to, and it no longer needs that line number to be stored on the go sub stack. But if you jump over the return instruction like this, we never tell the computer to ignore or remove that saved line number. So every time we execute this subroutine, it's going to continue to save that line number on the stack repeatedly over and over again on the go sub stack, which takes up memory in the computer, and eventually it will just fill up the memory in the computer and you'll get an error and a crash. So we don't want to jump out of a subroutine like this. We want to always let our subroutines return properly by hitting this return statement. And that should be fairly simple to do. I mean, it's not really a problem to let our subroutines hit the return statement, and we can always return at different points in our subroutine. So let's say we'll start again here. So let's say we have program 10 go sub 100, and then at line 100 is our subroutine, and I'll say rem subroutine. So here we're going to do stuff in our subroutine, line 110, and we'll do stuff. And let's say we want to check different conditions to figure out what to do with our program once we're in the subroutine. So let's say we want to jump back or return when a variable equals a certain value. So let's say if a, and I know I haven't assigned any variables in this program, but let's just assume these variables have been assigned in other places in the program. So we could say, let's say if a equals 3, then return line 120. If b equals 7, then return. And this is fine. You can have as many return statements as you want in a subroutine. As long as the subroutine hits one of them, then that will solve this particular problem. It'll return properly. It'll tell the computer to erase that stored line number off of the GoSub stack, and it'll free up that memory. Okay, so that's the second technique we want to be aware of not to do, is jumping out of a subroutine using a goto statement. We always want to return from a subroutine. Okay, so now we're going to take a look at a different issue, which is very similar to the last issue we talked about. But this time, instead of jumping out of a subroutine, we're going to talk about jumping out of a for next loop. So let's say we have a program here, 10 for f equals 1 to 3, 20 for f, 20 if f equals 2, then go to 100, 30, next f, and then maybe line 40, stop, line 100, print, now at 100. Okay, so if we go ahead and run this program, let's see what happens. Okay, so what happened is it printed this statement, which is exactly what we expected to happen. So it has a for next loop counting from 1 to 3. When that loop counter reaches the value 2, it jumps to line 100 and prints our statement now at 100, which is exactly what happened. But if we take a look at our loop counter variable here, f, print f, you can see our loop counter is at a value 2. So it never completed this for next loop properly. It stopped in the middle of it and jumped out. So I'm not sure exactly what technical effect this has on the computer, but I have run into issues with this before in my programs. In my Dungeon Quest program, I was jumping out of my for next loops, and then when I went to rerun that loop, it didn't work. So it's good practice not to jump out of a for next loop, and I'll show you a technique how we can exit a for next loop properly if we don't need it to finish all the way to its maximum counter value. So let's take a look at our listing here. So now what we want to do is edit line 20 so that we're not just jumping out of a loop using this go to 100 statement here. So what we want to do is say line 20 if f equals 2, then now what we're going to do is manually set this loop counter variable to its maximum value. In this case, it's going to be 1 above 3. So that's how a for next loop works. It counts to its maximum value, then it increments it one more, which in this case would be incrementing from 3 to 4, and that's how the loop knows that it's finished. So we're going to do that manually in this case. Instead of letting the next statement increment it for us, we're going to set it manually. So here we have if f equals 2, then f equals 4. So we're manually bumping up that loop counter variable to above its maximum value. And now we're going to add another command here, go to 30, which is going to jump to the next statement, where the next statement is going to find that the variable counter f is now above its maximum value, and it's going to stop the loop. So let's take a look at this program. For f equals 1 to 3, if f equals 2, then f equals 4, and go to 30. I guess we could rewrite this in a way that's a bit even more descriptive. If f equals 2, then let f equal 4 and go to 30. There. So now if the loop counter reaches the value 2, it's going to max out the loop counter to above its maximum, and it's going to set it to 4, and then it's going to go to the next statement, which is at line 30 here. And so then this will properly stop this for next loop from executing. Now, of course, you're going to need to add lines to the program to have it do whatever you want it to do after this loop has exited. If you wanted to here, you could add a go to statement after the for next loop. For example, at line 35, you could say go to 100. And if we run this program, it performs exactly the same as the previous program did, but now if we print our loop counter variable, print f, you can see it's now at a value of 5. So I think actually I don't need to set this to value 4, do I? I could probably set it to value 3 and it would do the same thing, I think. So let's try that. Well, I'm sure it would do the same thing, but let's try that. So I think I could say line 20, if f equals 2, then let f equal 3 go to 30. And this should do the same thing. It prints our now at 100 statement. And now if I print the value of the loop counter f, it's at 4. Yeah, so I think this is what we would do. We would set it to the maximum value and then go to the next statement, which is at line 30 here. And then if we want, we could have our go-to statement going wherever we want in our program. All right, so that is another technique we want to avoid, which is jumping out of a for next loop. Instead, we want to manually set the loop variable to its maximum value and then jump to the line that has the next statement in it. All right, so the last technique I want to show you as an example of something we should avoid doing in our basic programming has to do with data statements. So let's say we have a program where we have a variable initialization subroutine, for example, such as we might use with a game. So maybe we have line 10, go sub line 1000, and line 1000 will be our variable initialization subroutine. I'll say rem variable setup. And here we just assign some values to variables that our program needs. Maybe line 10, 10, maybe our number of lives, LV equals 3, 10, 20, maybe the high score, HS equals 500, whatever. And we're setting up our initialized variables that our program needs for the game. So what if we have several variables we want to initialize at once using data statements and a for next loop? So let's enter a for next loop to set up a string variable. So line 1030 for f equals 1 to 3. Line 1040, read a string f. And then line 1050, next f. So here we have at line 1030 through line 1050 a for next loop. It's going to count from 1 to 3. It's going to read some values and assign them to the string variable a string, which is an array, and it's going to assign them to elements a string 1 through a string 3. So now we just need to give the program some data. Line 1060, data. And let's say we want these values to be colors. So we could say the first value is yellow, and then red, and then magenta, just like that. And then since this is a variable setup subroutine, we need a return statement at the end. Let's say 1999, return. And so it'll return back to the line that called it, which in this case is line 10. And then normally in a program, you're going to have a main program loop that runs continuously, and it calls other subroutines as it needs to. So maybe our program is at line 100. Oops, I need to enter that. Okay, so let's say our main program loop is at line 100. Rem main program loop. Line 110, rem do stuff. And then you enter the lines of whatever your program is supposed to do. And then at the end of the main program loop, you jump back to the beginning of it. So maybe the end of our program is at line 500. Go to 100. So let's take a look at this listing. There we go. So now we have line 10. It calls a subroutine at line 1000, which is our variable setup subroutine. It sets up all our variables, including 3 text strings that's going into the a string variable array, and then it's returning back to our main program loop here at line 100 where it does stuff which I haven't entered, and then it just loops back here at line 500 back up to line 100, and it keeps executing the main program loop over and over again, which will call other subroutines as it needs to in our game. So for now, let's go ahead and run this program. And I think what I'll do is, instead of having our program execute endlessly in our main loop, I'll just put a stop statement here. Instead of this line 500 go to 100, I'll just put a stop statement. 500, stop. Okay, so now when we run the program, it should set up all these variables, go back to our main program loop, and stop. So we'll go ahead and run it. There, it's stopped at line 500, and all of our variables should now be set up. So let's check that. Let's print a string 2. And there we go. The value is red because a string 1 should be yellow, a string 2 is red, a string 3 is magenta. And our variables are set up correctly. Now, what if somewhere else in our program, maybe in the main program loop, we need to assign some other variables as the program is running? So for whatever reason, let's say we want to assign some variables within our program. So maybe let's say here at line 200, we want to use the same trick of using a for next loop to assign some other variables. So let's say at line 200, we do the same thing for f equals 1 to 3, and then line 210. This time we're going to use a different variable name. We'll say read b string f, and then line 220, we could say, well, we have 220 will be our next statement, next f, like that. So now we need to give this variable a list of data statements as well, or a list of data to put into the b string array. So let's say line 230 data. So now this time instead of colors, let's say we have fruit. So we could have banana, apple, pear. All right. So we'll take a look at our program now. And so here we have our program, which goes to line 1000. It sets up these variables, including the a string variable, which should be setting up the values yellow, red, and magenta into a string 1, 2, and 3. And then we have the b string array, which should have values banana, apple, and pear. So what do you think will happen when we run this program? Well, let's go ahead and find out. There we go. So it's run. It's stopped at line 500. And now let's take a look at our a string variable and see what values it has. Print a string 2, which before had a value of red, but now it has a value of apple. So why did that happen? Well, as you probably know, those of you who are familiar with BASIC, well, the reason this happened is the first time a read statement is encountered, it's going to use the first available data from a data statement as soon as it occurs in the program, the first time it occurs. So if we clear the screen and list our program, well, where is our first data statement? Well, our first data statement in the program is up here at line 230. And our second data statement is way down here at line 1060. And you say, well, yeah, but the for next loop is executing at line 1000 first, and then the program jumps back to line 100 and executes that part of the program second. Well, the computer doesn't care what part of the program is being executed. It keeps track of where the data statements occur within the listing of the program. So what's happening here is the program is jumping initially to line 1000 with our go sub statement, and then at line 1000 it sets up some variables until it gets to line 1040 where it hits this read statement. And even though we've set up a data statement very close after our read statement here at line 1060 with the data we want to go into our a string variable, since this is the first time the computer is encountering a read statement, it's going to go look for the first data statement in the listing, which is back up here at line 230. So when it's loading values into this a string array, it's going to get those values from the first data statement it finds in the listing, which is up here at line 230, and it fills it with banana, apple, and pear. So if we take a look at our b string array, now what do we expect that to find? Well, by the time this read statement for the b string array gets executed, these three data examples have already been used up. They've already been read. So banana, apple, and pear have already been read. So now the next available data is yellow. And if we print b string 1, we get yellow. So we have to keep track of our data statements and make sure that they occur in the right order that we want them to occur. So if we jump ahead in our program, we jump over a data statement, and then we try to read some data, remember that the computer is going to look for the data statements from the beginning and take the data from the first data statement that it finds and just go forward from there. So now, as many of you probably know, we can kind of get around this by using restore statements. What a restore statement does is it tells the computer, okay, forget about where the data statements occur in the program. I want you to use data starting at this line. So for example, when we go to line 1030 here and we execute this for next loop and the computer starts reading data for the A string array, well, what if we tell the computer we want to read data from line 1060? Well, what we could do is manually tell it to restore the data at line 1060, which tells the computer this is where the data starts. So we could enter a line here, for example, line 1025, restore 1060. And now when we run this program, what do you think will happen? Well, it's going to jump to line 1000, it's going to read data into the A string array, and it's going to take that data from line 1060 because that's where we told it to restore the data from. Like this. So at line 1000, we set up a few variables, then we hit this restore statement, and it restores the data starting at line 1060. But if we run this, you can see we get an out of data error message now in line 210. Why? Because we told the computer that the data starts at line 1060, but the computer doesn't know we have another data statement back here at line 230. So restore statements can be tricky because you have to know what your program is doing and where it's going to be executing these read statements. So although you could use a restore statement like this to manually tell the computer where to start reading data from, it's going to read data from that point on to the end of the program. And if you wanted to jump back to the beginning of the program to find some more data statements, then again you would have to restore that data manually as well. So there we go. We now have a few techniques and a few hints of what to watch out for when making our basic programs. Hopefully you found this video informative and useful, and hopefully it helps you to make some basic programs yourself, maybe some games or applications or whatever you like. So that's it for today. As always, thanks for watching, and until next time, take care. Bye for now.